This incident is based on the experiences of the UK P&I Club. Accidents like the one you're about to see can and do happen. As you watch this short clip, ask yourself, could this happen on my ship? A bulk carrier was navigating at night, with good weather and visibility. The bulk as officer of the watch, or OOW, was accompanied by an AB as lookout, with steering in autopilot. The OOW sighted a vessel approximately 1 point on the starboard bow. The vessel was observed on the radar at a range of 5 nautical miles. The radar target was acquired by ARPA, which indicated that the other vessel was crossing slowly and on a steady bearing, as to involve risk of collision. The target vessel was small and brightly lit, and the OOW identified it as a fishing vessel. When the fishing vessel was at a range of about 1.5 nautical miles, the OOW altered his vessel's course 22 degrees to starboard. He attempted to alert the fishing vessel using the bridge signal lamp. Shortly after the bulker altered course, the fishing vessel also altered course, so as to cross from port to starboard. After observing the fishing vessel's course change, the OOW altered the bulker's course again to port, to its original heading. The fishing vessel was very close on the starboard bow and altered course yet again, which caused it to collide with the bulker's starboard side. Investigators looked into what happened and found the following. The fishing vessel was sighted in good time. However, the OOW failed to take proper action to avoid collision. The bulker's alterations of course were too little, too late, to prevent a close-quarters situation with a fishing vessel. Early and decisive action could have been taken by the officer of the watch to avoid areas of fishing activity. The bulk carrier also failed to make use of sound signals to alert the fishing vessel crew. The following practices could have prevented this collision. Where there is risk of collision, take early and bold avoiding action, and monitor its effectiveness closely. Fishing gear can extend for long distances from a fishing vessel. A high state of alertness is required when navigating in the vicinity of fishing vessels. When navigating in or near areas of dense traffic, consider both reducing the vessel's speed and engaging manual steering. If in any doubt, call the master. Do not neglect to make use of sound signals, as required by the coal regs. In the event of a collision or suspected collision with a fishing vessel, be sure to communicate and provide all necessary assistance for saving lives at sea. Report any incidents to the nearest Maritime Rescue Coordination Centre and save VDR evidence. Now that you've seen this video, ask yourself these questions. What personal action can you commit to avoid an incident like this on your ship? What are the procedures and controls on your ship that would prevent this from happening? What could cause those procedures and controls to fail? What can be done to make the procedures and controls more effective? Thank you for watching this learning video. Please note that the UK P&I Club website has a wealth of further training and advisory material. Please visit www.ukpndi.com to find out more. This incident is based on the experiences of the UK P&I Club. Accidents like the one you're about to see can and do happen. As you watch this short clip, ask yourself, could this happen on my ship? A cargo ship scheduled an abandoned ship drill, which included lowering the starboard lifeboat and testing the on-load release mechanism. The second officer supervised the drill, and the bosun, oiler, AB and electrician also participated. At the end of the drill, the bosun tried to raise the lifeboat, but the electrical hoist winch did not work. The bosun then put a winch handle in, so he could turn the winch manually. At the same moment, without telling anyone, the electrician had gone to fix the electrical power source for the winch. When the power to the electrical hoist winch turned on, the manual winch handle spun suddenly at high speed, striking the bosun in the head. The bosun died instantly from the severe head injury. Investigators looked into what happened and found the following. When the bosun turned on the electrical controller and found that the winch motor did not run, he left the switch on in the hoist position, resulting in the winch and its handle rotating as soon as the electrician powered up the winch motor. The following operational and maintenance failures caused this fatality. First, there was poor communication between the crew members involved. Also, the electrical cutout, a safety device which prevents a winch motor from running while the manual handle is being used, did not function. Furthermore, the electrical cutout was not included in the planned maintenance system, and instructions for its inspection and maintenance were unclear. And finally, the responsible officer did not provide adequate supervision of the drill operation. Now that you've seen this video, ask yourself these questions. What personal action can you commit to avoid an incident like this on your ship? What are the procedures and controls on your ship that would prevent this from happening? What could cause those procedures and controls to fail? What can be done to make the procedures and controls more effective? Thank you for watching this learning video. Please note that the UK P&I Club website has a wealth of further training and advisory material. Please visit www.ukp&i.com to find out more. This incident is based on the experiences of the UK P&I Club. Accidents like the one you're about to see can and do happen. As you watch this short clip, ask yourself, could this happen on my ship? The duty engineer and oiler were assigned the task of replacing a damaged diesel generator exhaust gas thermometer, requiring a section of the exhaust manifold to be dismantled. Before starting the job, the crew members held a pre-work safety meeting and made all necessary tools and equipment ready. After first removing the manifold covers and a section of insulation to gain access, the engineer used a compressed air hose to blow away particles of dust and dirt from the exposed exhaust pipe. While doing this, he leaned backwards to avoid dust blowing into his face and lost his balance, falling from the platform onto the deck more than 2 meters below. The engineer was given first aid and hospitalized at the next port of call, where he was diagnosed with a broken collarbone and other injuries to his arm and shoulder. How did this happen? The generator engine platform was designed and fitted with a single fixed guardrail of about 1 meter in height. Without a middle rail, the engineer was able to fall between the rail and the platform when he lost his balance, while in a crouching position. After performing a post-accident assessment, the crew fitted horizontal chains halfway between the upper rail and the platform. At the time of the accident, the vessel was rolling and pitching in moderate sea conditions, which may also have caused the engineer to lose his balance. Although he was using eye protection, the engineer should also have worn a suitable dust mask when performing work of this nature. The following practices could have prevented this accident. A thorough on-site risk assessment should be performed to identify any potential hazards and required safety precautions. Elevated walkways, platforms, and openings should always be fitted with top and intermediate guardrails. If there is any risk of falling from height, wear a safety harness. Carefully consider the necessity of performing any work at height if the ship is pitching and rolling. Be alert to the possibility of loose tools and equipment falling from height or interfering with safe access. Be careful using compressed air. Never direct it at body parts, and always wear appropriate personal protective equipment. Now that you've seen this video, ask yourself these questions. What personal action can you commit to avoid an incident like this on your ship? What are the procedures and controls on your ship that would prevent this from happening? What could cause those procedures and controls to fail? What can be done to make the procedures and controls more effective? Thank you for watching this learning video. Please note that the UK P&I Club website has a wealth of further training and advisory material. Please visit www.ukp&i.com to find out more. This incident is based on the experiences of the UK P&I Club. Accidents like the one you're about to see can and do happen. As you watch this short clip, ask yourself, could this happen on my ship? In conditions of good weather and visibility, 2 vessels, one a small tanker and the other a large Cape-size bulk carrier, were heading in a northeasterly direction towards a traffic separation scheme. The tanker was proceeding at 10.5 knots on a course of 034 degrees true. Astern of the tanker, the bulker was proceeding at 12.5 knots on a course of 036 degrees true. The tanker's officer of the watch went onto both bridge wings during this period, but did not notice the overtaking bulker approaching from astern, as his attention was directed forward of the beam. As the vessels came into close proximity, the effect of hydrodynamic interaction pushed the tanker's stern to starboard, resulting in the bulker colliding with the port side of the tanker. The collision caused extensive damage to the tanker's port side hull structure, resulting in serious flooding. Investigators looked into what happened and found the following. The collision was principally caused by the failure of the overtaking bulker to comply with her obligation under Rule 13 of the coal regs to keep clear of the vessel being overtaken. A proper lookout was not being maintained by the officer of the watch on board the tanker by sight or radar over a full 360-degree arc of the horizon. As a consequence of not keeping a proper lookout, the tanker failed to take the appropriate avoiding action required of a stand-on vessel under Rule 17 of the coal regs. The following practices could have prevented this collision. A proper lookout must be maintained by all available means, including sight, hearing, and radar, over a full 360-degree arc of the horizon. Where there is a risk of collision, the giveaway vessel shall, so far as possible, take early and substantial avoiding action and monitor its effectiveness closely. Under Rule 13 of the coal regs, it is the responsibility of the overtaking vessel to keep out of the way of the vessel being overtaken. The vessel being overtaken as stand-on vessel is required by Rule 17 to keep her course and speed. The stand-on vessel may, however, take action to avoid collision as soon as it becomes apparent to her that the vessel required to keep out of the way is not taking appropriate action. When from any cause, the stand-on vessel finds herself so close that collision cannot be avoided by the action of the give-way vessel alone, she shall take such action as will best aid to avoid collision. Now that you've seen this video, ask yourself these questions. What personal action can you commit to avoid an incident like this on your ship? What are the procedures and controls on your ship that would prevent this from happening? What could cause those procedures and controls to fail? What can be done to make the procedures and controls more effective? Thank you for watching this learning video. Please note that the UK P&I Club website has a wealth of further training and advisory material. Please visit www.ukpndi.com to find out more. Based on the experiences of the UK P&I Club, accidents like the one you're about to see can and do happen. As you watch this short clip, ask yourself, could this happen on my ship? A bulk carrier was to bunker 250 metric tons of intermediate fuel oil from a supply barge. The bunkers were to be received in a pair of empty topside tanks, each with a capacity of 200 cubic meters. The company safety management system procedures stated that bunker tanks were not to be filled in excess of 85% capacity, which corresponded to a minimum ullage of 55 centimeters. The chief engineer delegated the task of performing the bunkering operation to the third engineer. After the bunker transfer hose was connected, the operation was started at 15:20 hours, filling only the starboard side tank. At 16:30, the third engineer recorded the ullage of the tank at 51 centimeters, and yet bunkering operations continued. At 16:35, he saw that the ullage had reduced to 35 centimeters. He rushed to the engine room to divert the bunkers into the empty port side tank. However, by the time he reached the valve station, the starboard side tank was already overflowing on deck, with oil spilling overboard. So how did this happen? This was a poorly planned bunkering operation, demonstrating a serious neglect of the company SMS procedures. The bunkering checklist was completed by the chief engineer on his office PC, instead of being done with the participation of the third engineer at the site of the job, resulting in some checks not being performed. The failure of the third engineer to closely monitor the filling of the tank and his lack of awareness of the minimum ullage figure led to a critical loss of control. He was not properly supported during the operation and was not in ready radio communication with other crew members or the bunker barge personnel. The bunker tank overflowed from both the forward and aft air ventilators. At the aft ventilator, the save all quickly filled up with oil, which then spilled onto the main deck. At the forward ventilator, the save all did not fill up, but oil was still able to escape because the drain plug had not been fitted. And although the main deck scuppers were plugged, oil was able to flow over the deck edge guttering and into the sea. The following practices could have prevented this accident. Bunkering operations should be performed in strict compliance with SMS procedures. Bunkering plans are to be carefully considered by the chief engineer and discussed with the bunkering team. Checklists need to be diligently completed at the site of the task, not treated as a tick box exercise. Bunkering is not a one-person job. It requires teamwork and good communication with ship and barge personnel. A save-all is not a save-all if the drain plugs are not fitted. Now that you've seen this video, ask yourself these questions. What personal action can you commit to avoid an incident like this on your ship? What are the procedures and controls on your ship that would prevent this from happening? What could cause those procedures and controls to fail? What can be done to make the procedures and controls more effective? Thank you for watching this learning video. Please note that the UK P&I Club website has a wealth of further training and advisory material. Please visit www.ukpndi.com to find out more.